Hello. Yesterday we took a look at adding and subtracting with our complex numbers. We learned that I equals the square root of -1, which I've written at the top of my paper here, and I squared equals -1. Today we're going to get into multiplying and dividing with our complex numbers. So let's jump right on in. The first one, we're going to do the distributive property. So with all of these, we're still going to multiply like how we would regularly, either using the distributive property or the box method. So this first one, I'm going to go through and distribute. If you need to put your arrows at the top, nothing wrong with that. 4i times 3 is 12i. 4i times -5i is -20i squared. We're not finished quite with this problem yet. I squared is equal to -1, so I can make a substitution here. So 12i minus 20 times -1. So what I did was made a substitution. I squared is equal to -1, so I'm making a substitution. So this problem turns into 12i plus 20. And generally, we do write the real part of the problem first and then the imaginary part. So this would be 20 plus 12i. So there we have it. We did the distributive property and we got our answer. The next one, we got two options for both E and F. I can do box or I can do distributive property. So one of them I'll go through and do box method, get a little refresher course on the box method. And then the other one I'll go through and I'll do the distributive property. So this is going to be 2 minus 5i. So 7 minus 3i and then 2 minus 5i. So we're going to go through and we're going to multiply. This is going to give me 14. This is going to give me -6i. This is going to give me -35i. And then this is going to give me 15i squared. So remember the box method from not too long ago? I'm doing the same thing here, except for now I do have some imaginary numbers that pop up. And that's okay. Now, I'm going to combine like terms and I'm going to make this be -15. I squared equals -1. So if I make a substitution in here, this box becomes -15. So again, this is I squared. I squared equals -1. -1 times 15. This box now becomes -15. So when I combine like terms, I'm doing 14 minus 15. When I combine like terms, that's -1. So 14 minus 15, they are like terms. They are the real parts of my problem. And then I put the imaginary pieces together. So that is -35i minus 6i. That gives me -41i. So that is recapping the box method. Now, the next problem I'll go through and do distributive property. So 5 plus 4i squared. I'm doing 5 plus 4i times 5 plus 4i. And I'm going to do the distributive property. So when you do that, it's 5 times 5 plus 4i. And then 4i times 5 plus 4i. Now I'm going to go through and do the distributive property. Now that I've set it up, actually go through and multiply. So this is going to give me 25, 20, another 20, and then 16i squared. These two are like terms, and I'm also going to change this I squared to -1, which is going to make this term a -16. So it's going to change the sign of our number. So now I have 25 plus 20i plus 20i minus 16. Combine like terms, I put my imaginary pieces together, and then I put the real parts of the problem together. So our final answer, 25 minus 16 is 9. And 20i plus 20i is 40i. All right, so that is multiplying with I. That is us multiplying with the complex numbers. If I squared pops up in your problem, make that -1. If you have a negative square root of 1 that pops up, make that I. Now, let's get into dividing. So in order to divide complex numbers, you must multiply both the numerator and the denominator by the complex conjugate. So in order to divide complex numbers, you must multiply both the numerator, which is the top, and the denominator by the complex conjugate. Now, I know that sounds fancy, but all we're going to be doing is changing the sign that's in the middle of our complex numbers. The reason we're going to do that is because it's going to get rid of the imaginary part of the problem when we multiply, and we're going to be left with only the real part of the problem. So this process is called conjugation. And since we're working with complex numbers, it's called complex conjugation. So let's take a look at this first one here. So 7 plus 4i times 2 minus, or divided by 2 minus 5i. When we're doing this, it's actually not even any dividing in the problem. It's going to turn into more multiplication. So we're going to multiply both the top and bottom by the complex conjugate. This is 2 minus 5i. We're going to multiply both the top and bottom by 2 plus 5i. So complex conjugate, this was 2 minus 5i. When you conjugate, you just change the sign that's in the center because some things are going to cancel out in the next couple of steps. So if it was minus, we put a plus. If it was plus, we put a minus. So we multiply both the numerator and the denominator by the complex conjugate. Now I am going to multiply on both the top and the bottom. Again, we have two options when we're multiplying. You can do the box method, or you can do the distributive property. I am going to distribute. But if you need to set up a box for the top part and a box for the bottom part, there is nothing wrong with that. Do what you need to get to the correct answer. But I'm going to do the distributive property. 7 times 2 gives me 14. 7 times 5i is 35i. 4i times 2 is 8i. And 4i times 5 is 20i squared. So that's on top. And then on the bottom, I'm going to multiply. 2 times 2 is 4. 2 times that gives me plus 10i. And then I got negative 10i. And then I have negative 25i squared. So what I did is I did the distributive property on the top and the bottom, so that we got our 4 different terms. Again, if you need to do the box method, nothing wrong with that. Now I'm going to start simplifying some things and kind of crossing some things out. So I'm only going to focus on the top for this time being. Okay. The 35i and the 8i can go together. They are like terms. And I could change this I squared to negative 1. So when you change it to negative 1, all it's going to do is change your sign. So now I have 14. 35i plus 8i is 43i. This is plus 20i squared. It now becomes minus 20. And on the bottom, I have some things I can do. This is going to cancel out, and this is going to cancel out. So we're left with negative 25i squared, which is going to become a positive 25. So now I'm left with 4 plus 25. Okay. Couple more things I can do. I got some stuff on top and bottom that I can simplify to. So I got some like terms on the top, 14 and negative 20. That's going to be negative 6 plus 43i. And then on the bottom, 4 plus 25 is 29. Now we got some options. I can leave it like this. I can leave it as negative 6 plus 43i over 29. Or you can break it up so that you can distinctly see the real parts and distinctly see the imaginary parts. So if you wanted to break it up like this, this would be fine. So you got options. You can leave it all like this, or if you want to break it up so that we can distinctly see that negative 6 over 29 is the real part of the problem, and 43 over 29 is the imaginary part of the problem. Circle. The end. So that is our answer. So notice we really didn't divide in this problem. We're multiplying both the top and the bottom by the complex conjugate. All right, moving on. Let's do another one so we can see that we're going to go through the same process. Let me see if I can fit both of them here for us to follow. All right, so I'm going to go through the same process, and I'm going to divide B. So I'm going to divide problem B. So we're going to multiply both the top and bottom by the complex conjugate. This was 2 minus 5i, so we did plus. This is 4 plus I, so we're going to multiply the top and bottom by 4 minus I. So multiplying top and bottom by 4 minus I. We can go through distribute, box method, whatever method that you like. I'm going to distribute. 5 times 4 is 20. This gives me negative 5I. I got 16I. And I got negative 4I squared in the numerator. So we did 5 times 4, 5 times negative I, 4I times 4, and 4I times negative I. I'm going to do the same thing on the bottom, distributive property. So that is going to give me 16 minus 4I plus 4I minus I squared. So whichever way you like, box or full. Now I'm going to simplify. I'm going to bring the 20 over. Negative 5I plus 16, those go together. That gives me 11. I got an I squared here, so by now we should know that's going to change this term to a positive 4. On the bottom, some things cancel. Negative 4I and positive 4I. This is negative I squared. That's going to change this to a positive 1. So this becomes 16 plus 1. And last thing I could do, I could go ahead and combine like terms on top. 20 plus 4 is 24 plus 11I over 17. So 20 plus 4 is 16. Bring the imaginary part down. 16 plus 1 is 17. And we can break it up into our two distinct parts. So 24 over 17 is the real part of our problem. And this is our imaginary part of the problem. Now, hopefully you do see a pattern, particularly in the denominator, that I want to point out. When you multiply by complex conjugates, your inside terms are going to cancel out. And what I mean by that, if I look here, I have positive 10I, negative 10I. They cancel. Negative 4I, positive 4I. They cancel. So if we look up here, if you're multiplying anything and all you're changing is the sign in the middle, something is going to cancel out because you're going to have the positive of that and you're going to have the negative of that. So a little shortcut that you could do, the more of these you do, you could just multiply the first and the last number. But that's going to mess you up, then just multiply the whole thing out by using box or distributive property. But multiplying by a complex conjugate, we do that so that we get rid of the imaginary part and we're left with only the real part.